Hello, friends. I'm Gautam. I will be explaining the part of the applying containerization mechanism involved in concepting application to deploy in edge device. So we'll be learning about the conversion of the application code into a doc container and the working steps and the description involved in it. So hereby I will be using Azure ML Studio for developing my model. So now let me share my screen for giving you the brief about conversion of the application code into a Docker file. Mm, okay. So to apply the containerization mechanism in the application to deploy in an edge device, we will be using the concept here like the containerization of IoT based temperature monitoring application for the smart temperature sensing use case that we have chosen as a topic for this edge deployment. So the problem description is that in IoT based system, data collected from various kind of sensors and the temperature humidity must be processed quickly at our near by a data source to reduce latency and network load. So we will be deploying such application manually on multiple edge devices that can be a time consuming and error prone. So hence containerization using Docker provide an efficient solution by packaging the application code dependencies and the um, application manually on the multiple edge devices. So that can be a time consuming and the error prone. So we'll be containerization using Docker provides an efficient solution by packaging the application code as well as dependencies environment into a single lightweight container that can be easily deployed on edge devices like Raspberry Pi, Jetson Nano, etc. So here the objective is to convert an Python-based IoT temperature reading application into a Docker container for edge deployment. So here we'll be using Docker um, containers and repositories. So the overall folder look like this. Smart temperature monitor. Here will be the application code to be converted into an container is an app.py file. Here is the simple temperature monitoring Python script that reads the temperature data as well as it can be used for sending it to a cloud or a local dashboard. So here is the simple threshold based mm, uh, condition checking for intimating the particular end user with a critical or a high level of predicted temperature. So this is the application code. So then we'll be using the working steps for converting the application into a Docker file that can be stated to be like installation of the Docker containers as well as various kind of things. So here we'll be using uh, install Docker for installing the Docker on our local or edge system and creating a project directory as well as adding the application file, place the app.py script inside this folder, particularly named as this smart temperature monitor. So creating a file named Docker file and add the following contents like using a Python based image as well as the copying the application code into a container here as a part of it, and then defining the command to run the application using this line. So the next file is building the next task is to build the Docker image using um, Docker build space hyphen T to make other the latest version of it and running the Docker containers. You will be seeing this running the Docker container will be like yeah, here is the Docker run command that is being used, and the Docker version has been installed local on the local system, and yeah, the step-by-step conversions include the application code that we have discussed, app.py, as well as the Docker file contents. Yes, here is the Docker file contents and the successful image creation message and running the container and the temporary. Here is the container based work and the temperature output and Docker PS is used for showing the active containers that is being a part of this kind of a thing. So yeah, let me show you the further kind of implementations. So the contribution of the each member in our team is that myself, Gautam, developed the application code and created a Docker file, and Naveen tested Docker build as well as the running on the local system has been done by him. And Savesh captured the screenshot and created a report and presentation, explained the edge deployment process. So the implementation summary is that the IoT app reads temperature data and the Docker container created with all the dependencies, particularly the requirements.txt file that has been used for the containing the particular dependencies as well as the versions and running on the local machines. And the final outcome is that the application has been successfully um, containerized using the Docker as well as the push command is being used, reduce setup time, ensure environment consistency. So I'll be assuming from the previous contents that our project flow was like the model training has been done using the Azure ML Studio and model registration and download has been done and the writing the inference or the scoring script followed by the environmental setup, Docker container creation and pushing to the registry and deploying on the edge device. So the smart temperature monitoring system collects temperature and humidity readings from the IoT sensors. So and humidity readings from IoT sensors using the trained ML model using the Azure ML Studio to predict and classify such as normal, high or critical. So that deploying this ML model to edge device helps in making the real-time prediction even without continuous cloud connectivity. To achieve this, this application is containerized using Docker, ensuring the same environment runs on both development and edge device. So application code, as we all discussed, is like the main.py and model. Here it is the temp underscore model dot pkl trained model downloaded from the Azure ML and the app inference.py inference script model loading as well as the prediction requirement.txt usually contains the dependencies and app to expose the REST API for prediction and Docker file has Docker configurations and the Docker file creation has been done with the lightweight Python image, setting the working directory as well as the installing the dependencies as well as um, finding the appropriate kind of exposing the Flask port running that application also. So to convert the application into a Docker container, installing the Docker engine as well as creating the desktop Docker desktop on this kind of local system and then the creating the image from the Docker file. So that can be done using various kind of a command like docker build underscore t command is being used for building the smart temperature monitor colon the latest listing all the Docker images as well as the Docker run underscore d underscore p monitor is used for starting the container from the build image, send test request using the curl command and other kind of API testing has also been done. Yeah, yes. Here is the API testing that is being used, right? So the API testing has been done, and yeah, the predicted temperature with the status is also being mentioned here. In case of some critical kind of a thing, we'll be receiving some more kind of an message known as the critical kind of a status for the threshold more than 50 or more than 55. We have been assuming the threshold values, sending the test request to the model endpoint and pushing the image using the dog, the continuous stream of values that is being identified as the critical values, as well as the pushing the image to the Docker hub or the registry, and pull command is also being used on the later purpose for pulling that and running on the particular edge in case the local system. So containerization on edge devices, like the advantages are lightweight and isolated runtime, consistent behavior across the devices, offline prediction, easy updates using new Docker images. So model training in Azure ML, Docker file creation and testing on edge has been done by me. Flask inference API and data integration has been done by the Naveen, and documentation presentation and other kind of score value has been done by Sarveshwar. So this is the local host running of the local host where we'll be seeing the smart temperature monitoring API is running. So when we use this test this using API, we'll be checking the critical temperature values that is being alerted by the user using the particular email or the message notification. So the in order to summary these points, the 8 steps to convert this application with the train model into a Docker container for its deployment is like building and training your machine learning model using this kind of an um, using this kind of building Python SDK as well as Azure reference visual reference, and importing the data set containing humidity, pressure, wind speed, and Fahrenheit values, and training using the regression model as well as splitting the data is done using the Studio. The trained model is stored, particularly in the case of the PKL file, and the evaluate model, and the register and download export model is being used, and the inference script is being mentioned in the inference script, and the Flask API is being used to predict the endpoint, prediction endpoint, and the environmental dependencies are here. The Flask as well as NumPy and Scikit learn libraries, and creating the Docker file has been done by defining the Docker image configuration for the particular ML application. So yeah, in order to give us summary, we'll summarize all those points, and the optional phase is pushing into an registry logged into the Docker hub and pushed to the image. It's also being done here. So yeah, we will be done doing this. So, the pushed username. Yeah, here are the implementations. Yeah. Pushing in the Docker using the command as well as the model trained in the Azure ML local REST API to get the prediction built from the Docker file running on the device and inputting the JSON file. So the final conclusion point by summarizing the conversion of an application container into a Docker using a Docker can be done like including the trained ML model as well as to deploy in an edge device and training the model in an Azure ML Studio and registering and downloading is being done and exporting the model, write inference or scoring script and defining the environmental dependencies kind of a thing. Um, Depending on this kind of using the requirements.txt file as well as creating the Docker image and pushing to the registry, deploying to an edge device, Docker, and optimizing for the hardware. So here is an output where we'll be checking the status, temperature, and the predicted value, as well as the continuous stream of values which are being mentioned as the critical values. Here is the Docker login command, as well as Docker tag and Docker push, and Docker the existing containers and stopping and removing the particular containers as being mentioned here. So yeah, here it is the curl command for testing the endpoints that is being mentioned. So yeah, pushing the Docker file has been done as well as pulling the Docker file and running the Docker pull command, Docker push command, as well as the Docker run command. So Docker tag, these are the other kind of a command and Docker build command. So these are some of the explanations of this kind of um, converting the application file into a Docker as well as deploying it into an edge device or deploying into a local laptop or any kind of a thing for the containerization part of it. It's been mentioned or discussed detailedly. So these are the kind of files that we have been using for the Docker as well as the containerization mechanism. Now, this is the final conclusion part. Thank you.